So what I'd like to do here is take a look actually at the function that we were just recently looking at, the function x cubed minus 9x squared plus 24x minus 12. And I want us to do a test on this function as well, but actually the test that I want us to run here is the second derivative test. So in the previous video we ran a value test on the first derivative. We looked where the first derivative was 0 or didn't exist. We then looked elsewhere to see if the first derivative was positive or negative. And the first derivative gives us information about slope, which tells us where the function is uphill or downhill. Here, though, we're testing the second derivative, which is going to give us information that second derivative yields related to the slope of the shape of the function. Because while first derivative gives you information about slope, second derivative gives you information about concave up or concave down. So, well, let's proceed with this. So first, in order to test the second derivative, you've got to have the second derivative. So first derivative is 3x squared minus 18x plus 24. We actually did this in the last video, but so be it. If you were given a problem like this straight away to find the second derivative, or to go through the second derivative test, you'd have to get to the second derivative. So let's do that. The second derivative, of course, the derivative of the derivative, that's 6x minus 18. All right, cool. So here is our second derivative, 6x minus 18. This is the function that we want to test. In order to go through a value test of this second derivative function, we need to test where this function has values of 0, where this function has values that don't exist. You can quite clearly see this function does not have a denominator, so that does not exist. The asymptotic case is not going to come into play. And then all we have to do is find out where this function has a value of 0. And that's actually not going to be too much sweat, because 0 equals 6x minus 18. Bring the 18 to the other side, divide by 6, x equals 3 is where this second derivative function has a value of 0. Okay, so let's take a look at our picture here to get a grip on this second derivative function. We know the second derivative function takes a value of 0 and 3. The question is, what are the second derivative values elsewhere? We're trying to run a test of the second derivative. Second derivative is 0 and 3. It's got to be something other than 0 elsewhere. So let's see what the value is elsewhere. So let's go over here, somewhere left of 3. In fact, since I can pick any value left of 3, I guess in the last video I just picked something close to 3, but you know what? 0 is to the left of 3, and that could be convenient to work with, right? So plugging in 0 makes life sort of easy. So let's take a look. Our second derivative function is 6x minus 18, so this would be 6 times 0 minus 18. You can see quite clearly this is negative. And so we know that our second derivative is negative to the left of 3. But think about what this means. Second derivative negative, that means the function is concave down. That means the function takes the shape of a frown. All right, so we've got a frowning shaped function going into the point x equals 3. And then what about to the right of the point x equals 3? We're going to need to pick a x value to the right of 3. Whatever we choose, is whatever we choose. And in this case, since we don't have 0 on the right side of 3, I'm going to pick a value that is indeed close to 3, because the farther I get from 3, the bigger the x values become and the harder the computation is. So I plug in that x equals 4, and I'm going to get 6 times 4 minus 18, 24 minus 18, I think that's 6, but whatever it is, I at least know this is positive. And that's really all we care about whenever we are value testing a function, because we don't care exactly what the function values are. Once we've identified where the function values are 0 or don't exist, everywhere else the function values are either positive or negative. And that's enough for us, because frankly, when we're talking about the second derivative, knowing when the second derivative is positive or negative tells you something. Because just like when the second derivative is negative, the function is concave down and takes the shape of a frown, when the second derivative is positive, the function takes the shape of a smile. So when you look at this now, you can actually say something about your original function. You can say that your original function is concave up on the interval from minus infinity to 3, and concave down on the interval from 3 to infinity. And in fact, you could say more, right? Because the point at x equals 3 is a point where the concavity changes sign, and we've talked about this as well. A point where the concavity changes sign is called an inflection point. So we've got an inflection point at x equals 3. By testing the second derivative, we've got information about concavity for our original function and actually have an idea of the general shape of the function from this.